Please, I am audible. Okay. So I think he left the meeting. Yes. Okay. So, dear participant, good evening, all of you, and welcome back to this session. Today we are going to discuss very interesting topic. For that, I have to share my screen, and without any loss of time, we are going to start. Okay. Phase, I have started the session. Okay. I thought you left the meeting. So the topic which we are going to cover is hypothesis testing, its application, and why the hypothesis testing is important for the machine learning. Okay, so let's discuss with the definition, and then after we have the real application, and when we will have the one more thing, I would like to inform you in the coming sessions by tomorrow or the next. Okay. I will assign you one project to all the participants so that we will work on machine learning project. Okay. So many things we have complete, and along with I will present one project based on the machine learning so that parallel to the same, you can also try to develop one project. Okay, so that you can be familiar about how we can develop a machine learning model. It's quite easy. Okay, so many things which we have discussed in the previous sessions. Okay, all type of the test and the procedure. Main thing is what is the right procedure for the project. So all the steps and the process which are required. Okay, partially we have covered. Now all the things we will cover in a systematic way so that you will be familiar about the complete process. If you need statistical analysis, you can do also. If you need to develop any machine learning model, you will be able to develop any machine learning model. Okay, so what are the techniques and how we can proceed? We are left, including this day, I think 6 sessions or more, 6 or 7. Okay, so we can easily complete. Actually, 2 days are enough to complete mini project. Okay, so that you can have idea about the machine learning, how we can implement, what are the complete process. And once you will complete one model, then after you can develop any model. Okay, only the algorithm will change or some techniques just like statistical method depend upon the data set. Okay, which type of the data set we have. Okay, so now you can see my screen. Okay, what is hypothesis testing? So hypothesis testing, yes, we will cover A/B testing also. Don't worry. All type of the test along with the which we need, we will discuss uh, in the coming sessions tomorrow or the next day. So all the type of the test which are required, we do here. So hypothesis testing is the statistical method used to determine whether there is enough evidence in the sample data to support or reject the claim about the population. So here we have two terms. One is the population and other is the sample. Okay. So suppose if we want to study about one state, whether any scheme which we implement for the farmers is beneficial or not. Okay, whether this can be beneficial or can be not. So for that, what we do, we take some sample in the form of because we will not able to get the all the farmers in the one particular state. So what we will do, we will take all the district, and from all the district we will consider at least so 100 farmers are there. Okay, so these are the sample. And many times when one have the disease, laboratory person take some sample, blood sample. Okay, they don't take the entire blood of the body, and you can see the result what happened. So actually, when for the entire population, we are taking some small sample, and on the basis of the sample, we can test that whether on the basis of this test uh, the any process which we implement for the farmers are valid or not. Okay, so we have to there is a one process and we have to follow accordingly. So hypothesis testing help us decide whether an observed difference relationship or the effect is statistical meaningful or could reasonably be explained by sampling variation. For example, a very simple example is here. You can say suppose a university introduced a new syllabus teaching method and wants to know whether it improves the students' average examination score. We can collect the data from sample of the student and use hypothesis testing to determine whether the observed improvement provided sufficient statistical evidence that the new method has an effect. Okay, so basic idea is this is the approach, how we can test, how we can implement, and along with we have several tests. Okay, so these tests are again very, very important when we will consider these hypotheses. So hypothesis testing begins with the two competing statements. First is the null hypothesis, and symbolically we denote it by H naught or S0. Okay, so the null hypothesis represent the default assumption, usually that there is no difference, no effect, or no association. For example, H0 is the notation and mu is equal to 70. Okay, this means that the population mean examination score is 70. Okay, so if we have the based on H0 and there is no effect, it means the assumption which we consider is applicable or true for the population also. And on the other hand, alternative hypothesis that we denote it by H1 or HA. Okay, so this is the symbol for alternative hypothesis. The alternative hypothesis represents the claim that we want to investigate, for example, H1. H1 is the alternative hypothesis, and here mu is greater than 70. This means that the population mean score is greater than 70. It means that is different from H0. Okay, so here these are the some two type of the hypothesis. One is null hypothesis and second one is alternative hypothesis. So how we can proceed after that when we assume hypothesis testing process is generally you can see here first is the research question. Then we have to formulate H0 and H1 as you can see in the above example. Okay. Then choose alpha. Alpha play very, very important role. Okay. So usually the value of alpha will be 5% means 0.05. It can be 0.01. Okay. Select the statistical test. Okay, so there are several tests which we are required to implement depend upon the type of the data set. Okay, so in the next we will discuss entirely how you can choose the test and what are the particular conditions, what are the properties to apply the test, because at this level we have to apply at one test, and on the basis of the test we can be able to decide whether accept or reject, and that is the value of P only. Okay, so select the test, a statistical test we are required to, and then after we have to calculate static and calculate the P value. On the basis of test static, we need to calculate the P value, that is also known as the probability value. And on the basis of this P value, we can make the decision. Okay, we can make decision and then after we can interpret. See now this complete example. Okay, this is the similar example. Suppose that the average examination score under an existing teaching method is 70. After introducing the new method, a sample of the student has an average score of 75. We may formulate just like you can see, H0 mu is equal to 70 and H1 mu is greater than 70. Okay, we have according to the sample student after the implementation of the new technique, we have a score is 75. So we have now two values. Okay. So if we by applying and testing, the value of p value is 0.02. Note this point. Okay, we have the process how we can calculate, but just here how you will decide. We have the only example when you have H0 and H1, and the most important value for us to get the to decide, to make the decision, only the p value is important for us. That is, suppose that the value of p is 0.02. Okay. And the significance level, the value of alpha. Okay. That is 5%, means alpha is equal to 0.05. Okay. So if this value, which we get here, p value is less than alpha, therefore, we reject H0. We reject H0. If the value of P is greater than and equal to alpha, okay, so that in that case, fail to reject. Okay, we will not say accept H0. We will say fail to reject. Okay, so here the P value is less than 0.05. That's why reject H0. So here the interpretation is also given. There is a statistical significance evidence that the 5% significance level that the new teaching method increase the average examination score above 70. Okay. And we have the test, and after applying the test, we see that the P is less than 0.05. The value of P is less than 0.05. So on the basis of this value only, we are able to decide whether accept or reject. Okay, so all the tests when we will apply, and we introduce here many tests, and several examples are there, and when you will get the static value as well as p value, but necessary part is to compare the p value. Okay, so there are two approaches. One is manual method, the other is computing method with the help of Python. So here we have the large data set. Okay, we are not doing the for the small data set or small values, but we have very large data set. On the basis of the data set, we are going to apply these tests, and according to these tests, we will check whether accept or reject null hypothesis. Okay, so for that, we are using just like library of Python, and we will have always two values. One is the static, okay, or name of the particular test. It's like a t-test. We have the ANOVA test, and there are so many tests are there which we are going to cover. But along with we have the value of p. So p will decide whether accept or reject. Only keep in mind only one part. P value is very necessary to calculate here to decide that decision. So why hypothesis testing are important? Hypothesis testing are widely used in healthcare. Does a treatment improve the patient outcome? When we are going to start any treatment on the patient, okay, so we want to check by using or by applying any test treatment whether the health is improving or not. Then the education, does a new teaching method improve the performance? Business, does a marketing campaign increase the sale or not? Okay, we implement one campaign to increase our sale. Okay, just like digital marketing is there in today's scenario, but many people or the businessmen are not able to check the output of this type of the campaign. So for that, we have hypothesis testing. Okay, so on the basis of this applying, we can check whether we have the engaged or not. Machine learning in the very much all type of the machine learning model is one model performance significantly different from the other another. Okay, so actually there are many models are there and we have to compare them. So how the one machine learning model is different from the other in the performance. Okay, in data science, is there any a significant relationship between the variables? And for the scientific research, does any experiment evidence support a proposed theory? Okay, because we always start from the theoretical part. And after that, by introducing some technique, we have to observe the difference. Okay, so we have to follow these two hypotheses. And after that, according to the data set, we have to choose one test. And on the basis of test, we will able to decide whether accept or reject. Okay. So these are some key points here. You can see the hypothesis testing provide a systematic framework for making evidence-based decision from the sample data while explicitly accounting for uncertainty. Okay, so this is all about why hypothesis testing, why we need to apply. Okay, so now we should come to the real data set where this the download. And here is what is this file, and there is one more file that is I think which I prepare for you. Yeah, statistical test with Python. Okay, these two files are there, which we are going to discuss right now in this session. So first we are required, yeah, this one. Okay, so actually, when we apply hypothesis testing with interpretation and real examples are given here. So, what is null and alternative hypothesis we have discussed already, and the significance level of alpha. Okay, along with I have to open one more file. Just one minute here in my download directory. I have prepared one more file that is cheat sheet. Okay, this also give you more detailed overview. I think this one. Yes. Okay, so here you can have more detail about the same. Okay, so here this is the what is the hypothesis in definition we have discussed already, and this is the null hypothesis and alternative hypothesis. Okay, so if we have mu not equal to mu naught, that is two-tailed. If the value which we see that example which we discuss, if that is greater than mu zero, then we have right-tailed. If that is less than, then we have left-tailed. Okay, if not equal to mu zero, it means that can be either greater than or less than. So in that case, we have two-tailed. Okay, these are the types of alternative hypothesis test. And the example which we present here is this one. Okay, which we discussed for the teaching method. So here, these are the values of alpha. Alpha can be 10%, alpha can be 5%, alpha can be 1%. But all of the cases, we are always use alpha is equal to 0.05. Okay, so this is the decision rule. P-value. If p-value is less than alpha, reject as 0. If p-value is greater than and equal to alpha, fail to reject as 0. This is the decision rule. This is very, very important. Okay, and here in this diagram, you can see the p-values. Okay, so here is if we have this is the two tail actually, left side and right side. So half p by 2 is in this side and half is in this side. Total we have is p, and this area which you can see 1 minus p. Okay, and this is the interpretation you can see as we have discussed already. And types of one error and type two error. These are given here. So here you can see reality. In reality, H0 is true, H0 is true, and H0 is false. There will be always two cases. Either it will be true or either it will be false. Okay, in reality, there are two cases for H0. H0 is true, and here H0 is false. And on the basis of decision which we get. Okay, so here reject S0, reject S0 and fail to reject S0. Okay, so this is the decision and this is the actually reality. What is reality is there. Okay, so when we reject S0, but here S0 is true. This is type 1 error. If we have reject S0 and here S0 is false. Okay, so in that case, this is correct decision or positive, true positive. Okay, and here is also you can see if the decision is failed to reject, but actually S0 is true. Okay, see this one, this row and this column. See here, correct decision, that is true negative. Okay, and if we fail to reject S0 and here S0 is false, this is type 2 error, false negative. So these are two type of the error. One is type 1 error and another is type 2 error. And we have to keep in mind, actually these are not important when we will apply. Okay, so theoretically part, if you need to understand for the examination purpose, we are required. But when we deal with the real data set, only in that case we need only p-value. So all type of the test when you will apply and you will observe that the p-value is only important. Okay, so if you need some more information about all this, so I introduce here and you can easily go through, and this is the complete process as we discuss in the file. Okay, and always we will take the value of alpha 0.05. So this is the overview about this how you can choose the value of p and the other thing. Okay, so only the value of alpha, which will be always 0.05, and this is the decision rule which you have to keep in mind. Okay, so only these two things are required to keep in mind while you will apply this test on real data set. Okay, so now come to main point here. So these are some type of the test you can see here: real world interpretation, one sample data test, statistical power, statistical plus practical significance, etc. So this definition part, everything we have discussed already. I can skip this part. Okay, so yes, all these things are there in the cheat sheet also, and the same information I put here. This is the p-value, and this is the rule of decision rule. Okay, based on p-value only. Okay, p is less than alpha and p greater than or equal to alpha. Okay, less than reject to S0, and if p is greater than or equal to alpha, fail to reject. Okay, so here you can see the value of alpha is 0.05 and p is 0.018, and this value is less than, then reject S0. So here come to our yes. So the methods also are given here, just like test static. This is the formula. Okay, one sample t test is there, one tail test. Okay, if mu is greater than, mu is equal to 70 and mu is greater than 70, this is one tail. If we have at this place mu not equal to 70, then it becomes at this place, if we have mu not equal to 70, okay, it means it can be greater than 70 or it can be less than 70. In that case, it will be two tail. And okay, these are the only steps which are required here. Here our main purpose is this is the way how we can apply. Import x bar, the value of mu, s, n, and this is the t state. Okay, the formula is same as you can see, t state formula. is given here. Yeah, this one. Okay, so all the values are given here. Directly, how you can implement in Python. Okay, so by using the Python, t static value is a 2.7386, but this value is not sufficient because we need, with the p value. Okay, without having the p value, we can't decide. So if you are doing manually, then by using this value, we have the process to get the p value. But here you can see, yes, this is the complete example how we can implement. See here, we are importing numpy as np. This is the numpy, and along with we are importing here scipy import states. Okay, here we take very simple example. The data constructed to illustrate the reported scenario, mean is 75 and the sample SD is approximately 10. So these two values are given here. Okay, and this is the score which you can see. This is the score. And we have the data set. Okay, so you can see the values are in this data set. So what we can do, first we will check here sample the size. Okay, length scores by using this variable. What is the size of this data set? Then after sample mean, we are collecting here round NP dot mean score. Okay, so here up to 2 decimal places. So round function we have applied at this place so that we can have exactly up to 2 decimal places. You can use up to 3 decimal, or you can use only 1 decimal. According to your choice, you can change this value to. And then sample standard deviation. So here also you can see NP dot STD formula is there, scores and d of is equal to 1 and 2 we are using. So by using these all statement, we can have these values which you can see here. So here you can see the sample size is 30, mean is 73.85, and then sample standard deviation is 5.63. Okay, so here you can see this is the mu 0. Mu 0 is 70. And the value of alpha which we have taken at a place is 0.05. Okay, so on the basis of these two value, okay, we are going to apply one sample t-test. Okay, so here you can see t state, p two-sided state. Okay, this is the way how we can write. The two values always. When you will apply any test, whether it is a t-test or ANOVA test or the other test, so we have always two values. One is t state and other is the p value. Okay, and this is the test you can see. Stats dot t test we are using one sample. Okay, and score means which we have these values. Okay, this variable, and population mean, this is the population mean is mu 0. Population means is population mean we have taken here, that is population mean. Okay, this is the 70. Okay, this is the population mean. Okay, which is given to, which we taken at a place. Okay, so then after when you will apply this test, this will return two values. Okay, so convert one side p value for h1, mu is greater than mu 0. This don't matter. So here we have to apply the condition. We have to apply the condition. Okay, so here is you can see we are converting p value for mu is greater than mu 0. Okay, so if t test is greater than 0, t state is if t state is greater than 0, so p1 side is equal to p2 side less than 2 divided by 2. Okay, we convert it in by half. Okay, so for that you can see here when we don't have for this case, just 1 minute. Where is the image which I open? for this case. Okay, so either this side or this side. Okay, here the test which is applied here, the test which we apply here, this one. Okay, but for one sample. Okay, so we have to convert one side p-value for h1, mu is greater than mu 0. So what we can do here for this is the p1 side. Okay, so this is the value, and p1 side the other, that will be 1 minus p2 sided by 2. Okay, then after the values which we compute at the place and print t static value, that is t value. Okay, around t state which will store here at this place, that will we print here up to 4 decimal. Then we have the two-sided p-value and one-sided p-value. So this value is the two-sided, which you can see here. So that will be same, will print at this place. Okay, and by using this part, we convert the same value in one-sided p-value by using this one. If t stat is greater than 0 and p one side, okay, or else p one side 1 minus this one. So this will convert either left side or the other side. Okay, so this is the p value one side. You can see will print here. So if p one sided is less than alpha, this is the decision rule which we are going to apply. Okay, so for our purpose, p value is very, very important. Only p value. Okay, see here, if p value is less than alpha, alpha is 0.05. Okay, if less than, then decision reject as 0. And also we put here conclusion. This is the conclusion. The conclusion is that there is a statistically significant evidence that the mean score is greater than 70. Okay, the assumption is rejected. As if the p1 value is greater than alpha, then decision failed to reject as 0. Okay, so the conclusion is there is insufficient evidence that the mean score is greater than 70. We don't have sufficient evidence that the mean will be greater than 70. So here we fail to reject. Okay, so now when we will apply these conditions, okay, so only this line, okay, all the other tests you will see for the different tests. So we always get two values. Okay, and from these two values, p value is very, very essential. Without having the p value, we are not able to decide whether reject or fail to reject. This will make us our decision. So if we have two-sided, then we have to convert p one side. As you can see here, we are required to convert in one side. Okay, so here you can see when you will execute again, and we have stats of okay. I have to start the file from very beginning. Now I can do from this place because the system was shut down. That's why all the outputs are there in my file. But when I restart, so we had to start from the very beginning, so that the libraries which are essential can be imported, and then after we can apply. Yes, you can see here these values. Okay, so this is the static value. This does not make a decision. Okay, decision will be only the based on this value, and you can see this value is less than 0.05, very small value as compared to alpha. Okay, so the decision is reject as 0, and this is the conclusion according to because in every statement we make like in this way, so that automatically we can have the decision. And sometimes if you need some more interpretation about this one, so later on when we have the machine learning model, okay, so this is the way how we can apply the test. So first thing is all type of the tests which are exist for the null hypothesis testing, okay, how we can implement them directly by using the Python. Very quite simple, and all the tests are well defined. Some are their properties, some conditions are there. We have to keep in mind all these conditions. Okay, table form is also I will provide you so that you can go through and you can keep in mind all type of these. Okay, so some certain method are usually we have to apply repeatedly, and but there are many tests, but all the tests are not much useful for data science. Some of the selected method we will cover here. Okay, so here this is the healthcare example. Okay, and you can easily go through this example. This is the complete, you can see the complete hypothesis testing rule. Okay, so what you will do in the step number step one, then you the step two, step three, step four, step five. Okay, these are the different tests are there. You can see Z test is there, T test is there, F test is also there, chi-square test is also there. Along with we have the ANOVA test is also there. Okay, so one of the tests we have to apply. Okay, depend upon again, this will depend upon the data set, which type of the data set you have. And one test we have to choose according to the data set, according to the problem. But for that, we have to need to understand the test and their application, which type of test you can apply for what under condition. Okay, so all these are defined. So these are the step how you can apply all these tests. Okay, so this is the overview about this test. These are the some examples. Not to worry about all this. Now see this file. Okay, here we write like Z test, T test, paired T test, chi-square test, ANOVA test, non-parametric test. All these we introduce here, which are highly useful in AI, ML, and data science. Okay, and all these will be applicable when we have the hypothesis test which are required. Okay, so one of them we have to choose according to this. So what for each test we cover? Purpose, application, hypothesis, condition, Python implementation, decision rule, and interpretation. So all these things I try to introduce here so that this can be helpful for you. Okay. So here these libraries are important, just like import numpy as NP, pandas as PD, and scipy import state, and import states model.api as SM. And when you will execute, all the libraries will be imported here. And once again, I execute all the entire file so that I can save the time. Yes. So this is the decision rule. Now come to very first test. This is the Z test, purpose. Okay. So a Z test can be used to test a population mean or proportion when the sampling distribution can reasonably be treated as normal. For the classical one sample mean Z test, the population standard deviation sigma is known. Okay. The value, when this value is known, only then you can apply this Z test. And this is the formula. Okay, this is the formula x bar minus mu 0 upon sigma upon under root n. Okay, so all these values are known. Okay, what are the conditions? See, number one, independent observation. Number two, continuous outcome for mean test. Number three, population standard deviation known for the classical one sample Z test. Okay, so standard deviation is there. Normal sampling distribution or appropriate large sample approximation. Okay, for example, you can see here a company claims that the machine produces the component with an average length of 50 mm. Given that the sample mean is 52, population SD also given, and sample size are given. Okay, so H0 mu is equal to 50. This one which is there. And H1 we will consider here mu not equal to 50. Okay, so this is the complete Python programming, sample mean, mu 0, sigma, n, the formula which we have used there, then p value we can calculate by using this one. This is the way how we can calculate the p value. Okay, for this z test specifically, here we will calculate the z value. Then after we will apply to get the p value, because without having the p value, we are not able to decide. Okay, so p value is very essential. So 1 minus stats dot norm dot CDF absolute value of z, which will be calculated by using this formula. Okay, so this value will be used here at this place. Then by using this formula, which you can see here, will return us the p value. Okay, so then after we will print the values of this, and alpha, we always take 0.05, and this is the decision rule. So this decision rule will appear in the same way as we discussed in the previous example and the other examples. Okay, so there will be always a p value will be either less than alpha or greater than or equal to alpha. So if p value is less than alpha, in that case we have reject S0, and interpretation you can see here. And otherwise, as means otherwise. Okay, if this condition is fail, this condition will fail either p value is equal to alpha or greater than alpha. So in that case, we have this decision. Okay, fail to reject S0, and interpretation there is insufficient evidence that the population mean differ from 50 mm. So when you will execute, you have all these values. Z static is 2.5, p value is 0.012 something, and this p value is less than 0.05. Okay, you can see only this value will decide. All type of the test when you will apply, okay, whether it is Z test or T test, ANOVA test, those or F test, okay, those values are not sufficient to decide. Only the p value is there. We have to calculate p value, and without having the p value, we are not able to decide whether reject S0 or fail to reject S0. Okay, here you can see the one more example, T test. Okay, so when we can apply t-test, this is very important. T-test is commonly used to compare means when the population standard deviation is unknown. We don't know about the standard deviation. Then we can apply. And common forms, these are three common forms you can see. One sample t-test, independent two sample t-test, okay, and Welch t-test. So with respect to all, we have the examples, one sample test. Okay, this example we have already discussed. IUMC claims that the average examination score is 70, and these are the hypotheses. See the conditions. Okay, with all the tests we give condition so that you can be familiar under which condition we can apply the particular test. Okay, so we keep in mind all the conditions about the test. To apply the test is not a problem. Problem is that under which condition, which test we need to apply for the hypothesis testing. Okay, this is the important part. Okay, this is nothing. We can do everything. And the coding part we can do. Okay, these are very simple. Not a big problem. The data set, whatever you have, here you can see the small data set. Okay, you can have 1,000, you can have 10,000, you can have 50,000, you can have 1 lakh, 2 lakh. Okay, size doesn't matter, but the matter is under which condition, which test you are going to apply. So the conditions we have to follow for each test. Okay, so here you can see the same here directly by using the roundup, and then you can see we are calculating here p value stats.t test one sample score, and population mean is 70, and here you can see the t static and p value. Okay, so alpha is 0.05, and here the same conditions are there, and you can see the p-value. This is also, you can see here, less than 0.05. Okay. Similarly, you can see the two sample t-test. Two sample t-test. Okay. So when we have the two samples, and first we assume that mu1 is equal to mu2 and the other will be mu1 not equal to mu2. See, comparison scores under two teaching method. We are applying two different methods and we want to test them. Okay, for that Welch t-test is used here. So this is the way how you can apply. This is the traditional. Okay, and here you can see AI method traditional and AI method LB dot array. Okay, we want to compare these two both. Okay, so see here how we can do t state, p value, and see here stats dot t test underscore independent. This is one method that is a traditional, and this is AI method. Okay, these are two methods, and both are independent. Okay, so we combine here traditional, comma, AI method, equal variance false. And then after you will use here print Welch t-test static value. Okay, that will round up, and the p-value that is also round up. Okay, so these both value, t static as well as p-value, will be computed by using this function. Okay, so t static and p-value both will be always there whenever you will apply any test. So here you can see this is the same way, no difference, there is no difference. Okay, so when you will apply this test, you can see the t static value is minus 6.6307, p value is 3e minus 0.6, and this value is very, very small. This value is very, very small, but sometimes because we are not able to understand what is the meaning of this value. Okay, and reject as 0. So what you will do? We can copy and come to this is the simplest way. Okay, many times we have to use generative AI tools. Okay, so that you can have the also how we can integrate or how we can use it. Just one minute. Where should I open? I can open here. Here is ChatGPT. Yes, so the value which you get, the p value is, you can see now, this is the p value, 0.000003. Okay, so sometimes if you have the difficulty, you can take help from generative tool. You can put there and ask her to interpret. So this the complete interpretation is there. Okay, everything. So p is less than this one also. The hypothesis of equal population means was reject. So this will help for more detailed interpretation. You can take help from the generative AI tool. This will help you for the better understanding, for more detailed interpretation. Okay, so now come to back here. Yeah, this is the paired t-test. When you will apply purpose, see, a paired t-test compares two related measurement. Typical application you can see before and after. What was the condition before the treatment and what was the condition after the treatment? Pre-test, post-test. Same patient under the two conditions. Same student before and after the training. Okay. So the person is same, the prompt is same before and after. Okay, so these are the conditions you can see, which is the are natural paired and pairs are independent of other pairs. Difference score and approximately normal distributed for the small sample and no extreme outliers in the difference. So these are the conditions under which you apply. So here you can see this is the data before and after. Two type of the data set are there. Okay, and you can see how we can apply. These values are always there. We have the t state and the p value. And here you can see stats dot t test underscore relevance before and after. Okay, so this will compute these two value when you have the data set. Okay, paired before and after. Before the test, after the test, before the treatment, after the treatment, before the training, after the training. What is the change there? Okay, so you can see, and this is the same way. We will get this value, and the other part which you can see here is same thing. No difference in any example. So when you will implement, only this statement will change. Only this one. Because here we are going to apply the test. The other parts which you are observing are in the same way. You have to print the value of a t state, you have to print the value of p value. But the p value is more important because on the basis of the p value, we are going to decide whether reject or accept. Fail to reject. Okay. So here you can see the p value is 0. Again, you can see the chi-square test. Okay. So when you will apply the chi-square test, so chi-square test are mainly used with categorical frequency data. When we don't have numerical values. Okay, so important application, what are the important application? Chi-square test for independence. And the second one is goodness of fit. Okay, here you can see the example, chi-square test of independence application. A healthcare researcher wanted to determine whether smoking status is associated with the disease status. Okay, so here the disease, no disease, smoker, non-smoker. So here you can see the smoker 40 and non-disease 20, non-smoker 25, and here is 45. Okay, hypothesis you will consider according to the problem H0 smoking and disease are independent and H1 smoking and disease are associated. Okay, so these are the hypotheses. Now, conditions, variables are categorical, observations are independent, data are frequency count, expected frequency should generally be sufficiently large, and Fisher's exact test may be preferable for 2 by 2 table. Okay, so you can see these values which are there and same are here. Okay, this is the table. Then we are going to apply the chi2 p value degree of freedom expected. Okay, state dot chi2 underscore contingency table. So this is the way how you can apply chi-square test. Only this line, this statement is important for us. So the other values which you will get by using we have these values. Okay, so here you can see we can print all these values. This is the chi-square, then p value, degree of freedom, and expected frequency. Okay, so then after C, this is the decision rule. The decision rule will be always same, and we need only the p value. From all these values, only the p value is important. Okay, only p will help you to decide what you should do. Okay, so here you can see the chi-square static value is there, p value is there, degree of freedom is 1, expected frequency, you can see these are the expected frequency, but on the basis of this p value is less than alpha. Alpha means 0.05. This is 0.0000083. This value is less than 0.5. Okay. So you can see reject as 0. Okay. So actually the thing is to apply the test is not a big problem in Python. The problem is that how to choose the test. Okay. For that you must be familiar about first thing is complete process. What are the processes? How will implement a hypothesis test? Okay, and there are various test type of the test, but this test when you will apply depend upon your data set, which type of the data set is there and what you are going to do with your data set. Okay, so I tried all this method as simple as I can do for you. Okay, so here you can see the application part is there, condition is there, process how we can implement with using Python is there. So everything with each method is clearly defined. Application part also is given there so that you can easily understand all these tests and their application part. And the same thing will happen when we have real data set. Again, I'm saying size doesn't matter. Matter is that you need to understand the data set. And without having the understanding about your data set, you can't decide which method you need to choose. Okay, that's why I'm saying repeatedly, the understanding of the data set is more important. The other things which you are observing are very quite simple. This is not the problem. The problem is that how and in which manner you are understanding your data set. As much you have the more information and understanding about your data set, all the things will become very simple. There's nothing any problem. The problem is only to understand the entire data set and according to that, what you can do. That will decide your deep understanding about all these tests, their application, and in the same way, the problem in machine learning models. Okay, which model when we can apply under which condition, under which type of the data set. Okay, so all these understanding matter a lot. Application part and implementation part is not a problem. This is very quite simple. Similarly, you can see the next method, chi-square, goodness fit is there. Okay, application. This is the one example. Okay, and here also, okay, observed frequency is there. Just like for a die, each expected frequency. And okay, here conditions are not defined. Okay, I will give you the conditions about this test also, and you need to follow. So we want to test whether the observed frequency are consistent with the fair die. Okay, so this is the method how we can apply. This is the observed and this is the expected. And chi2 p-value and chi-square is there. And actually there are observed and expected. Okay, both are there. And we apply here the method and you can see the decision. Then we have the ANOVA. When we can apply ANOVA method, very famous, very popular. And there are some statisticians are there. They know very well the importance of ANOVA test. Anyone please? Highly useful. Yeah, Ganesh Kumar. Yes,
Can I repeat your question, sir?
Sir, my question is when we can apply ANOVA test
So if
and
you
its
have,
type.
if you have more than three or more variable,
Okay.
then if it is discrete data also part of that, there we can use ANOVA.
So is there one-way ANOVA and a two-way ANOVA?
Yes, sir. One way and two way ANOVAs are there, sir.
Okay. What are the difference between one way ANOVA and a two way ANOVA? Is there any particular condition? Okay, see. Okay. So one way ANOVA is used to compare the means of three or more independent groups. Okay, three or more. So here is the example. Compare the exam score from three teaching method. Okay, and F static method is there between the group variation upon within group variation, between group and within group. Okay, so these are the conditions: continuous independent observations, approximately normal residuals, and homogeneity of the variance for the classical ANOVA, and no saver influential. So here you can see the application part. These are three methods are there. Okay, and here we will apply F state and P value. Okay, so the application part is very quite simple. Stats.f underscore one way. Okay, so all the methods which we have, you can see method A, method B, method C, and then after we have the value, and the value will be static and p value. Okay, so here we have f static and p value, but for our purpose, this value is important. Okay, and this is the important part. This part will be always same in all the tests, because this will decide the decision reject or fail to reject. Okay, so this will automatically return the output. So in that manner we write all the code so that easily automatically we have the output according to the p value which will be computed here. So when you will execute this shell, you can see f static value is 54.1609, p value is 1e minus 06. So reject, this value is very small. Okay, so you can copy and use the generative AI tool. Okay, so this is like 0.00001 something. Similarly, you can have the, okay, this the duck is HSD post HOC test. Okay, so if ANOVA is statistically significant, duck is HSD can identify which pair of group differ. Okay, you can use this one also. Okay, and this can be applicable only if when ANOVA is statistically significant, then we need to apply this. Okay, so here this is the way how you can apply. This library is required to import here because this is the a different method, and stats model dot stats dot multi computing and import pairwise underscore cookies HSD. Okay, all scores we have to concatenate all this, okay, by using concatenate function. Okay, so this is the method A, method B, method C. Then after groups, okay, so we have to multiply all this with length of A plus this also with the length B, and then plus this also multiply with the length C, and this is the method. Okay, how you can apply this method? So Tokis is equal to pairwise underscore Tokis HSD, then and dog is equal to R scores, comma, groups is equal to groups, and alpha is 0.05. So when you will execute, so we have this summary. You can see. Okay, so this is the comparison. This is the comparison. Group A, group B, and then you can see the mean difference, P adjective, lower, upper, reject, all these are there. Okay, so this also you can use for comparing after it is significant. And what about the non-parametric test? Anyone apply this test before in your future, this test?
Actually, see, we don't go this detail level, sir. We have option in statistical tool like SPSS mini tab, right? We can choose the data and execute the test that will be give ANOVA table, all kind of thing. So internally, it's binded this kind of test. Generally, not get into the detail level here.
Okay.
Statistical tools have a binded thing actually.
Mm-hmm.
See, I am not using Python. I am using SPSS, Minitab,
Okay.
RStat, and they're all not get into this detail. It's directly ANOVA table, and output will become.
Yes,
So
yes.
we'll check that.
Yeah. In SSPS, we need only to upload the data set, and after that, we have all the information.
Exactly.
Yeah.
And
But in R programming also, R and Python are just like similar type.
yeah. Yes, I
Yeah.
got it.
Okay. So you are using R and SPSS, right?
R and Minitab. SPSS in my previous company I used, but in
Okay.
current company I'm not using SPSS. I'm using Minitab, it's a statistical tool, and RStat. Both I am using.
So I think there is one more tool, Stata. Mostly statisticians are using Stata.
Stata we are not using, sir. SAS also
Okay.
we are not using.
Mm-hmm.
These three tools only.
Okay. So actually, this is a good thing. You are a very solid background from static. So, what do you feel the difference between Python and R if you are already using 2, 3 tools, and this is, I think, first time you are attending this Python programming for static purpose?
Python I tried, sir. I'm not comfortable because it has its own programming. But R is not like that. The R is statistical package, its own statistical package. So if you know SQL, if you know something around SQL, then you can easily understand the R. But
Mm-hmm.
Python, we need some programmatic knowledge, basic knowledge we need.
Actually, the difference between R programming and Python is that in the Python we have the libraries and the modules, but in the R programming we have the packages. So according
Yes.
to our need, we use them. Okay.
Yeah, it has
So
its own package, sir. So it
yeah,
is
packages.
easy to call and use it, and there are varieties of packages.
Yes.
There is
R is
varieties
very
of
simple.
packages. Yeah, R is very simple. Yes.
As compared to Python. But actually, when we think to develop just like a machine learning model, or after developing the model, then we want to deploy. Deploy means we want to develop something mobile application or web application, then we have to use this Python.
Mm, yeah.
Okay, otherwise, all these things we can do easily by using R programming and SPSS.
Yeah. So model building R is sufficient, sir. But if you want to go for in detail building large application using the model, deep
Mhm.
learning, those kind of thing, Python is required.
Yeah.
But if you see only for model building purpose, find
Yes.
out which is good model, right?
Mhm.
That R is sufficient actually.
Good.
In my
Yes.
view, I am telling my view. Yeah.
Hmm. Dr. K. Kavita, I think you are also from a state background.
No, sir. No, sir.
Okay. Sir Ganesh Kumar, where you are working?
I am working in Chennai. Product is I am part of data analysis and BI team. I am leading the team actually, data analysis and BI team. But
Okay.
mostly we are using Power BI, R,
Uh,
and Excel, SQL. That's all the three, four
Sequel.
tools we are using.
Hmm.
Yeah.
Good.
Minitab and all we will use if we want to do some, testing, some model, some data. If we have simple
Uh,
data, then we use
uh,
Minitab. But
okay. Sir,
mainly
please
we are
share
using
your CV with
R
me,
for.
okay? Ganesh sir, please share
Yes,
your
sir.
CV. Please share your CV with me.
Sure, sir. Sure. Definitely.
Yeah.
Definitely.
Okay.
Yes, sir.
So, what about the non-parametric test? Anyone can please help me?
The non-parametric is non-normal. Like data is not normal. Typically, people check using non-parametric. We did for one sample t-test, two sample t-test for normal data,
Hmm.
right? Same
Okay.
set of thing we have to do for not normal data means non-parametric this will be used.
Hmm.
Non-parameter means which we are not considering the number. See, Z test, T test, F test, we are seeing that a number based only, sir. So this is
Hmm.
my opinion, but I don't know that actual thing. Non-parameter. Like chi-square
Opinion.
test, it
Yes.
comes to that
Yeah.
non-parameter, right?
Opinion always welcome from each side. Okay. So if we have the nice discussion, we have more clarity about the concept, and if there is any gap, we can easily cover. Okay, that's why if any more want to explain about the non-parametric or parametric test. Okay, actually we have discussed already the parametric, just like t-test, pair t-test, all these are parametric. And non-parametric test you can see on the right hand side. Okay, so some of the examples are given here. So will you try all these yourself? It is about 10 p.m. Okay, so if there will be any problem, we can discuss tomorrow coming session. Okay, so the application part and the use of all these are very quite simple. There is no
Sir, can
any
you
big
use
difference.
that? Actually, I'm involving right now this month cancer treatment the project, sir. Can you
Okay,
go with that the first one treatment before and treatment after? Is it suitable for that, sir?
yes.
Yeah, sir. Okay. So
Hmm.
that you mentioned that a paid t-test is not appropriate. Okay. Then we need to
Yeah.
go.
Yeah. So
Oh,
this file will be available with you. Just now I will share with you.
sure,
Okay,
sir.
and very useful. And all the content, just like I have one PDF file from the hypothesis testing, and then after these are two files where all type of tests are there. Okay, and one cheat sheet is there where all type of the two cheat. I will share with you two cheat sheet. Okay, so one cheat sheet I have shown you, one is there also. So all this content I will share with you, and you must try and apply all these examples. Okay, this will take very less time, and the application part is very quite simple in Python. Just in the very beginning, which type of the tool and the method and how you will use it. Okay, and the essential libraries which we need for this type of the test to apply the test, state is there. Okay, so we have to import the state, and after that the required packages we can mention, and after that we can easily apply all these tests. Okay, so this is all about the today's session. It is now 10 p.m. approximately, so you can try all these other tests. Okay, will you try? So here we have the statistical test selection cheat sheet is also there, you can see. Okay, so the research questions, parametric test, non-parametric test are there, and this is the complete hypothesis test workflow is also once again given here, and at the end we have the some questions. So very less tests are there. So I request to please go through this detail yourself. Okay. Uh, Dear face, are you there? I think he
Sir?
left the meeting.
Hello, sir.
Hello, Dr. Shyam Sundar. How are you,
Yes,
sir?
yes, sir.
How are
Sir,
you?
here you're that means generating those variables, values, but it would have been better if you showed it by importing from CSV files, and then what are the codes that will be we have to change when we import the values from the CSV file.
Sir, repeat again. Generative AI.
No. If we have to import the values from the CSV file, you are generating the variables.
Yes. I will in the coming session by
Yes, sir.
tomorrow.
Yes,
All
sir.
these things will be on a real data set, because in the one session we clear the some concept so that we can easily use there. We are not required to clear the concept, all these things, and you also will be updated all of the test. Okay, so this will
Okay,
be
sir.
very easy to implement when we have the real data set. We will import the data set and in the previous session also we do the same thing, and in
Yes.
the coming session by tomorrow also we are using the real data set and how you can use all this. So by tomorrow what we will do, we have the real data set, and before applying all these tests we have to prepare the data set. Okay, just like there can be the empty shell or
Yes, sir. Yes.
all these things we will prepare the
Pre-processing, sir.
data for using all type of the statistical analysis. Okay.
Okay.
And the same process will be applicable for the machine learning model.
Yes.
So I will try to present to start one machine learning model. Okay, so
Yes.
that I can also assign you one model to each participant so that you can also complete, so that how the machine learning model we can apply and how we can compare them, how we can check the accuracy, etc. All these things we can do. Okay,
Yes.
so this is all about the today's session. Any
Okay, thank
more
you.
question, please? Okay, thank you, and good night. Tomorrow we will start the session at the same time. Okay, other participant, some are the student. If they have also any question, don't worry. You can freely ask the questions. Okay, Engineer Prakash, Payal. Payal, I think you are a research scholar, right? Yes. So, okay, thank you and good night. Tomorrow we will start the session at the same time. Good night. And
Thank you, sir.
enjoy all this content which I present here. All this will be available in WhatsApp group.